Photoelectric spectroscopy is a process in which you bombard a substance with energy and measure the electrons that are released. This process helps you identify which elements are present. The x-axis is measured in electron bonding energy, or how much energy you add, and starts at 0 on the right and goes upward as you travel to the left. The y-axis is the relative number of electrons released and starts at 0 on the bottom and proceeds upward. The peaks are represented by energy sublevels, such as s, p, d, and f orbitals. They start on the right because the energy is lowest on the right, and it takes the least amount of energy to remove valence electrons. So if you're going to look at a graph and analyze it, you'll start on the left and you count up on energy levels and orbitals as you would for electron configuration. The peaks you can see differ based on the amount of energy needed because there are more electrons in p orbitals than are in s orbitals. So starting from the left, you have the 1s2 orbital, the 2s2 orbital, and then the next peak is the 2p6 orbital, followed by the 3s2 orbital, and then the 3p6 orbital, and finally you get to the 4s2 orbital, which in this case is half the size of the other s orbitals, as you can see, which means that half the relative number of electrons are released. So instead of having a 4s2 orbital, it is 4s1, which completes our spectrum. From the orbitals that we found, we can use those to compile the electron configuration of this element by using the peaks in the order that they are shown. We can put together the identity of this element. We can use the configuration that we found from the graph to identify the element using a periodic table. So we start with the 1s orbital, which covers hydrogen and helium. Then we go 2s, 2p6, 3s, 3p, and finally 4s, to find that our element is potassium. Here we have another example, so feel free to pause the video and work this one out yourself and hit play when you're ready to see the answer. So once you've identified the orbitals, you can find that this element is gallium.